Okay, I hope I'm audible to all students who are attending this practice lecture for the basic mathematical methods for economics course. In this particular practice lecture, we look at some worked out problems. We look at some worked out problems on the topic functions in one variable. These problems which we are going to do will be based on concept of straight lines, parabolas, circles, functions in one variables, polynomials, which we have covered in our basic mathematical methods for economics course. Okay, so let's look at some of these practice problems. Let's look at question number 1. Find the distance. Find the distance between the following pair of points. Find the distance between the following pair of points. So I'm writing the points and we need to find the distance between these pair of points. Okay, so we are given the point P, coordinates are -5, 2, and we are given another point Q, the coordinates of which are -3 and -4. Okay, so let's quickly find PQ, the distance PQ. Okay, recall from my modules on coordinate geometry, how do I find the distance between the two pair of points? Suppose this is x1, y1 and call this as x2, y2. PQ is nothing but the square root of y2 minus y1 square plus x2 minus x1 square. Or you could have also taken x2 minus x1 square plus y2 minus y1 square. The order doesn't matter in that case. So I can write -4 -2 square plus x2 is -3 minus -5. Minus of -5 is +5 square. So I get -6 square plus 2 square, which is the square root of 36 plus 4, which is the square root of 40. So my distance PQ is equal to the square root of 40. Okay, so I hope students have understood this. Then let's move to the next part. Question 1, part 2. We are given the points P, alpha minus beta, and we are given another point Q, which is minus alpha comma beta. How do I find the distance PQ? This is x1, y1, x2, y2. So my PQ is the square root of y2 minus y1 squared plus x2 minus x1 squared. This is beta minus of minus beta, which is plus beta squared, plus minus alpha squared. So this is 2 beta squared plus minus 2 alpha squared, which is 4 beta squared plus 4 alpha squared. If I solve this up further, I can take 4 common. In the bracket, I can write beta square plus alpha square. 4 comes outside, becomes 2. So 2 times the square root of alpha square plus beta square. This is my answer for question 1, part 2. Let's look at another part, the last part of this question, question 1, part 3. Again, we are given 2 points, 81 square to 81. This is my coordinates of point P. And Q, the coordinates of which are 82 square to 82. How do I find PQ, the distance PQ? This is x1, y1, x2, y2. How do I find PQ? That's the square root of y2 minus y1 squared plus x2 minus x1 squared, which is 2a p2 minus 2a p1 plus a t2 square minus a t1 square. So if I work this out forward, I can take 2a common here, so I get t2 minus t1, plus I can take a common here, so I get t2 square minus t1 square. Within this, I can write 2a times t2 minus t1, and using the identity a square minus b square, I can open up and I can write t2 square minus t1 square as t2 minus t1 times t2 plus t1. In the bracket, I can write the identity I've used. T2 square minus T1 square is T2 minus T1 times T2 plus T1. So if I now factorize, I can write this as, so within this whole expression, I can take T2 minus T1 common. In the bracket, I get 2a plus a times T2 plus T1. Okay, so in fact, I could have also taken a outside the bracket. So if I do that, if I take a outside the bracket, I can write a times t2 minus t1 times 2 plus t2 plus t1. So I get 2 plus t2 plus t1. So this is my answer for PQ. Okay, so I hope that students have understood this. Okay, there's a small mistake. It is squared up, guys. This is squared up. This is further squared up. So y2 is this, y1 is this whole square. I forgot to put the square on the top. X2 is this, x1 is this, again squared up. So if I take 2a common here, it's within the square, so it's going to be 4a square. This is going to be 4a square. Let me solve this again from here. In order to give perfect clarity to all students, let me solve this problem again. So my PQ is going to be, I can take 2a common. So 2a times t2 minus t1 whole squared up. Now this is correct. Plus a times t2 square minus t1 square whole squared up. So if I further simplify, 2a square is 4a square times t2 minus t1 square plus a square times, now t2 square minus t1 square I can write as t2 minus t1, t2 plus t1 whole squared up. Okay, so therefore my PQ is going to be 4a square times t2 minus t1 square plus a square times, if I open this up, I can write t2 minus t1 square, t2 plus t1 squared. So therefore, my PQ is going to be, now what can I take common? Within this expression and this whole big expression, I can take a square common. I can take t2 minus t1 square common. So in the brackets, I get 4 plus t2 plus t1 squared. This is what I get. Where once I take a square times t2 minus t1 square common, I get 4 plus t2 plus t1 square. And now when I solve this, my PQ comes out as, so this, if I remove the square root from here, I get a times t2 minus t1. When I take it outside the square root, inside the bracket, I get t2 plus t1 square, t2 plus t1 squared plus 4. This is the final answer for this question. So I hope all students have understood this. Okay. First, we apply the distance formula, distance between two points on a straight line. Okay. We apply the formula. Then we put in the coordinates. Then we take certain terms common, we factorize, and then we get the final answer. So I hope all students have understood question number 1. Let's now look at question number 2 for practice. Find the coordinates. Find the coordinates of the point which divides the line joining 2, 4 and -1, 2 in the ratio 2:3. In the ratio 2:3. So let's quickly solve this. It's based on the section formula, which I have covered in my lectures on coordinate geometry within my basic mathematical methods for economics course. Okay, so how do we find it? So let's take 2 points. Let's call them as P and Q. Suppose the coordinates of P are 2, 4 and the coordinates of Q are -1, 2. Okay, and let's say R divides PQ in the ratio of 2:3. So this is x1, this is y1, this is x2, this is y2. Okay, this is M and this is, let's say, N. What are the coordinates of R? So I can say let x comma y be the coordinates of the point R. Then using the section formula, I can write that x is equal to mx2 plus nx1 or m plus n. M is 2, x2 is -1, n is 3, x1 is 2 over m plus n, 2 plus 3. This is going to be -2 plus 6 over 5. This is 4 by 5. And what will y be? M y2 plus n y1 over m plus n. M is 2, y2 is 2, n is 3, y1 is 4 over m plus n, 2 plus 3. So this is going to be 4 plus 12 over 5. 12 plus 4 is 16. So my answer is 16 by 5. So the answer for this question is the coordinates of R, so Rxy, the coordinates of R are 4 by 5, 16 by 5. Okay, I hope all students have understood how we have applied the section formula. Let's look at problem number 3. Find the ratio. Find the ratio in which the line 3x minus 2y plus 2 equal to 0 divides the segment joining the points 4, 2 and 1, 5. Okay, so again, we need to find the ratio in which this particular line divides the line segment joining 4, 2 and 1, 5 in the particular ratio. Okay, so suppose I can say that let the line, again, it's an application of the section formula only. Let the line 3x minus 2y plus 2 equal to 0 divide the segment joining, suppose 4, 2 is represented by point P and 1, 5 is represented by point Q. In the ratio, let's say k is to 1, where k can even be a fraction now. Suppose the line divides the segment in the ratio k is to 1. Okay, so now what will be the coordinates of this particular? So now we need to first of all find out what will be the equation of the line joining 4,2 and 1,5? So first of all, let's work that out. So if I draw a diagram, first of all, I can say this is P 4,2. This is Q 1,5. And let's say there is a line which divides it in the ratio K is to 1. The equation of this particular line is, let's say, 3x minus 2y plus 2 equal to 0. Okay, so suppose this line cuts the point PQ at the point R. Suppose the coordinates of R are x comma y. Again, I can write this is x1, this is y1, this is x2, this is y2. Using the section formula, what will x be? It's going to be k times 1 plus 1 times 4 over k plus 1. So my x comes out as k plus 4 over k plus 1. And what will my y be? Again, using the section formula, k times 5 plus 1 times 2 over k plus 1. So this comes out as 5k plus 2 over k plus 1. That means my coordinates of the point R are x has come out as k plus 4 over k plus 1 and y has come out as 5k plus 2 over k plus 1. Now this point R lies on this line. It means these points must satisfy equation of this line. So I can erase the initial part and I can write, we all know the question now, we need to find the ratio. So erasing the initial part, I can write that since point R lies on the line 3x minus 2y plus 2 equal to 0, therefore it must satisfy the equation of this line. It must satisfy the equation of this line. So 3 times, what's the x coordinate of R? K plus 4 over k plus 1 minus 2 times. What are the coordinates of, what's the y coordinate? 5k plus 2 over k plus 1 plus 2 is equal to 0. So guys, what we have done is, in this particular equation, I've put the coordinates of R, which are k plus 4 over k plus 1 and 5k plus 2 over k plus 1. And now I'm going to just solve this equation for k. So if I erase all this off now, let's solve for k. And that is going to give us the answer. So erasing all this off, let us look at the value of k. So I can say that 3 times k plus 4 over k plus 1 minus 2 times 5k plus 2 over k plus 1 plus 2 is equal to 0. I can take k plus 1 as my LCM. So I get 3k plus 4 minus 2 5k plus 2 plus 2 times k plus 1 equal to 0. This gets multiplied here and becomes 0. So 3 times k plus 4 minus 2 times 5k plus 2 plus 2 times k plus 1 is equal to 0. I can open up the brackets, 3k plus 12 minus 10k minus 4 plus 2k plus 2 is equal to 0. 3k plus 2k is 5k and 5k minus 10k is minus 5. 12 minus 4, 8. 8 plus 2, 10. So I can write 10 is equal to 5k. This implies k is 2. So my answer is, my required ratio is k is to 1, which is, what is k? 2. So my required ratio is 2 is to 1. So this is the final answer for this question. So I hope that all students have understood how we have solved for this particular problem. Let's look at the next problem. Okay. So we have done question number 3. Let's look at question number 4. Find the equation of a line passing through. Find the equation of a line passing through the points 4, 5 and -3, -2. Now we know from the lectures on coordinate geometry how to find the equation of a line joining 2 points. Let's call this as x1. So let me write it here. So we are given the points. So I can write here that the points given to us are, let's say, P 4, 5 and Q -3, -2. Suppose this is x1, y1, x2, y2. Equation of a straight line. Recall this from my theoretical lectures. Equation of a straight line passing through the 2 points x1, y1 and x2, y2 is y minus y1 is equal to y2 minus y1 over x2 minus x1 times x minus x1. What is y1? 5. What is y2? -2. Y1 is 5. X2 is -3. X1 is 4. And x1 is again 4. So y minus 5 is equal to -7 over -7 times x minus 4. -7 cancel off. I get y minus 5 is equal to x minus 4, which implies y is equal to x minus 4 plus 5, 1. So y is equal to x plus 1 is my answer. This is the required equation of the straight line. Y equals x plus 1. So hoping all students have understood this. What form we have used? We have used the 2-point form for finding the equation of a straight line. Let's move to the next problem, erasing this part off. Question number 5. Find the equation of a straight line. Find the equation of a straight line that cuts off an intercept -4 on the y-axis and slope equals 1.5. Okay, so again, recall from my lectures on coordinate geometry, we are given the y-intercept and we are given the slope. What's the equation of a line? So equation of the straight line with C as the y-intercept and M as the slope is given by y equals mx plus c. Check out my lectures on coordinate geometry. When you are given the slope, which we call as m in our lectures, and when we are given the y-intercept is where the straight line is cutting the y-axis. So the y-intercept is c, slope is m, equation of the straight line is mx plus. Now in this we are given that the y-intercept is -4. So c is -4, and we are given that the slope is 1.5. So therefore, what's the equation? Mx plus c. M is 1.5, c is -4. This is my answer. This is my answer. So I hope then all students have understood this. This is where I intend to stop in this particular lecture. We have covered 5 problems for discussion. In this particular lecture, as far as Theta-Hammond book is concerned, you will find all these topics in functions in one variable. Okay, so I have done similar kind of questions which are there in Theta-Hammond, and the topic we have covered today is straight lines. In the next lecture, we are going to practice some of the more problems on straight lines. Okay, so I can say that in the next lecture, in the next practice lecture for mathematical methods for economics part 1, or I call it as the basic mathematical methods for economics course, we are going to look at more problems on straight lines. So I stop in this particular lecture. I hope all students have enjoyed this lecture. Any doubts, you can unmute your mics and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolofelconomics@gmail.com. This is where I stop in this lecture.